Hi everyone, in this video we want to start actually evaluating logs, seeing if we understand what a log is asking us to figure out. And I've got a big list here, but I've grouped them up in order. The first few I'm hoping we notice some particular facts about logs along the way. So if we've been following along with this whole relationship between exponential and log form, we know that if y equals b to the x, that gives us the exact same information as saying that the log base b of y is equal to x. So we know the log is looking for the power that we apply to base b in order to get y. Which means that when I look at this statement, I'm trying to find the log base 2 of 2. The question I should be asking myself is, what power do I raise the base to get the input? I don't know why that one is mini. And the answer is, if I want to raise 2 to a power and get 2, the power better be 1. All right, next one. We're still using log base 2. So now the question is, what power of 2 will give me 2 to the third? And that's looking like it should be a third power. 2 to the third gives you 2 to the third. And these are deliberately set up so that we can spot it really easily like that. Again, I'm hoping we notice some stuff along the way here in these first couple. Third one, 2 to what power will give me 2 to the fifth? That's the question that log is asking. And that, I think, is number one thing to practice when you're doing this, is just how to ask yourself the question, what does it mean to take the log base 2 of 2 to the fifth? It means find the power that you would apply to a 2 to get a 2 to the fifth. And that's going to be a fifth power. If I apply a fifth power to 2, I get 2 to the fifth. Okay, let's work through the next row, and then I'll point out a couple of things that I hope we're starting to notice. Log base 5 of 5. So this is saying what power of 5 will give me 5? And the answer is a first power. This one is saying what power of 5 will give me 5 to the negative 1? And the answer is a negative first power. And this one is saying it has a typo. Let me fix it. There we go. Supposed to be saying what power of 5 will give me 5 squared? And the answer is second power. Okay, so things to notice, but I want to be really clear. I'm going to generalize a couple of things that I hope we're spotting in these 6 log problems. But I don't think these are rules that you should be memorizing. I think if you understand logs, these are things that will be very obvious to you. So I'm more pointing it out as, if this isn't obvious, that means you need to keep thinking about how logs work. And that's the whole point of this first section on logs, is just to practice until they really start to make sense. So I'm going to group this pair together first and see if we can generalize what we're seeing there. I only gave you 2 examples, but I think it might be enough. What I'm seeing in both of those statements is that I'm taking the log base something, we'll just use b for a variable for base, of that exact same something. So if you take the log base b of b, it appears that you're getting 1. And if we think about this statement, that seems exactly right. If I ask myself, no matter what b is, what should I raise b to get a b? The answer will always be 1. So again, these generalizations, I don't want you to have to memorize this. I want this to be something that eventually becomes really obvious to you when you ask yourself, b to what power gives me b? You don't have to memorize that that's 1. That just makes sense to you. So it's just pointing out some things that are true in general. Okay, now I want to look at all 6 of them and see if I can find a little bigger generalization. And I'm even going to put a first power on these to kind of help with that. You can put parentheses or not around these. I want you to be used to seeing it both ways. Okay, so what I'm seeing in all of these is, again, I have this matching up of my b and my b, but there's also a power here. So if I take the log base b of b to some number, I'm just going to use x, it appears that I just get that number. And even with the 1s. Okay, and again, I hope this makes sense actually on 2 levels. Firstly, if I look at this as a general statement and I say, what power of b gives me b to the x? The answer certainly better be x. So I hope that makes sense to you. There's also another level to this that I think we should not forget about. We're kind of working just on logs as an operation, but we don't want to forget that our real goal here is to build up another family of functions, the log functions, that are the inverses of exponentials. So if we're thinking about functions and inverse functions, I hope this makes a ton of sense to you, because the entire reason that we created log functions was to be the inverse of exponential functions. What we're doing here, plugging an exponential function into a log function, that's composition. And anytime you compose inverses, you should always get back what you started with. So there's our getting back the identity function x. So absolutely for this section, you should be working on just understanding logs as an operation, but try to keep some of that function thinking in your head as well, because that's the point of all of this. Okay, so there was a couple of generalizations. Let's look at this row. See if we can come up with another, and then the rest are just practice. So log base 3 of 1, we should be asking ourselves, what power of 3 will give me 1? And the answer to that should be 0. If you raise something to the 0 power, you should get 1. The only exception is 0 to the 0. We don't want to do that. That's undefined. Otherwise, raising something to the 0 power should give you 1. This one gets into one of those logs that doesn't follow our general rule about notation. If you see log without a base, you're to assume that it has a base of 10. So this is asking me what power of 10 will give me 1. And once again, I would say the answer should be 0. If you raise something to the 0, you get 1. And this is another that doesn't follow our typical rules for notation. Whenever you see the ln, that's a natural log, which means your base is e. So this is asking you what power of e will give you 1. And again, the answer is 0. So to generalize here, if we are taking the log base b of 1, we should always get 0. I shouldn't need to write any restrictions on the fact that we don't want to get 0 to the 0, because the rule about logs is their bases are always positive and not equal to 1. So I don't have to worry about that happening. No 0 to the 0s happen there. Okay, once again, I hope this is not something that you have to memorize. What my hope is that you recognize these patterns and that they make a lot of sense to you if the log is making sense to you. So if I ask myself, what power of b will give me 1, the answer should always be 0 for any base that's legal for logs. Okay, so I think that was the end of my generalization. The rest of these are just some practice. And you'll have a little bit of this practice in your homework, and if you feel like that's not enough, you're not super fluent with logs, there's also a worksheet that I found online. I think I called it worksheet of 1,000 logs or something like that. There's tons of them, 900 and some of these, and the answers are all in the back. So if you need more practice, you want to just keep evaluating logs until it becomes really quick and easy for you to find those answers. So lots of practice on this is great. Remember, this is an exam where you're not allowed to use your calculator, so you should not be using a calculator when you're doing any of this homework. Okay, so the log of 0.001, so that's 1,000th, and I actually think it's really helpful to think of it that way. Since this is a log that doesn't have a base, we should be asking ourselves what power of 10. So the question this log is asking is, what power do I apply to this invisible 10 to get 1/1000th? And you can just write it 0.001, but personally I kind of like thinking about it as 1/1000th, because I know that 10 cubed is 1,000, which means if I want to get 1/1000, I have to raise 10 to the -3. If you struggle with these at all because you're not good with your negative exponents or fractional exponents, things like that, you should also be able to find in WAMAP a little bit of exponents practice, just raising numbers to different funny negative and fractional powers. So I highly recommend doing that if you're at all mixed up about negative powers, fractional powers, things like that. Okay, so 10 to the -3 equals 1/1000. As I've said, you should be trying to do this without a calculator, but if you want to use your calculator as a check, that's legitimate. I would say number one thing is try to never touch the log buttons on your calculator for now. We want to understand all this in terms of exponents. So if you need to do a quick check to make sure you're not mixing up exponent stuff, you could always go and type in 10 to the negative 3 and make sure you get what you want. And that looks pretty good. So that I would say is an appropriate use for studying purposes. But again, don't be reliant on that. You won't get a calculator on this test. All right, log base 6 of 216. So I wanted this one particularly because since you're not having a calculator, I want to be clear about my expectations. I don't know powers of 6 off the top of my head. To make sure everyone's on the same page here, the question is, what power of 6 will give me 216? But I know that 6 to the first is 6, and I know that 6 to the second is 36. So I'm guessing I don't have to go very far beyond that. You're not going to see huge powers because it gets really cumbersome to try and figure out what's happening. So I would make a guess that maybe it's 6 cubed, which is going to be a 36 times 6, or maybe 6 to the 4th. And we should be able to do a quick check of powers as long as they're not crazy big. So 6 times 6 is 36. 6 times 3 is 18, 19, 20, 21, and that looks perfect. So it looks like if I multiply 3 sixes together, I get 216. So again, you're not going to be running into things like 6 to the 7th power on a test where you don't have a calculator and have me expect that you could figure out what that is. So don't feel like I expect you to multiply out something like 6 to the 7 or 5 to the 6 or any of those. 5s are a little easier, but I still think that's pushing our luck. 2s, however, I am not shy about asking you for big powers of 2. And this next one is all about that. So you should be able to count off some powers of 2 or figure them out somehow. Here, the question is, what power of 1/2 will give me 128? So right off the bat, I can see, so this is kind of my side work, that I need a flip in there. So I'm going to say, well, I definitely need a negative power to turn it into a 2. And then I need to figure out how to turn the 2 into a 128. So if you're trying to turn something between 0 and 1 into something bigger than 1, you're probably going to want a reciprocal, negative powers. If you're trying to turn something bigger than 1 into something between 0 and 1, you might want the negatives to flip that as well. Okay, so this is what I'm saying with powers of 2. This is the one where I'm not going to be nervous about asking you to be able to figure out some higher powers of 2 because I would hope that we could count those out fairly easily. So 2 to the 1 is 2. 2 squared is 4, 8, 16, 32, 64, 128. So that was 7 2s that I had to multiply together. So basically what happened here, let me make myself a little side note, is I took 1/2 and I raised it to the negative first power, and then I raised it to the 7th power. If you raise something to a power and then raise it to another power, that means you should multiply those powers together if you want to combine that into a single step. So I needed a negative 7th power. Flip it and raise it to the 7th. So again, if you have trouble with the negative exponents and the flipping, just practice some exponent stuff. I find that some people get what the log is asking for, but they really get in trouble on this test just because they're not good with exponents. So there is practice, and if you need more practice, talk to me. All right, this one is asking what power of 16 will give me 2. So I do want my number to get smaller. I'm trying to shrink from 16 down to 2, but I don't want to flip it. I don't have a number between 0 and 1. This isn't a reciprocal of 16 anywhere in here. So the way we shrink numbers without flipping them is by using roots. So for example, the square root of 16 would be 4. That shrunk, but not quite enough. And you can always do this one step at a time. A square root is a 1/2 power. Here, I'll leave myself room so I can write it all out. And that gets me 4, but that's not quite good enough. I want to get down to 2, which means the 4 also needs a 1/2 power. So the 16 needs to get square rooted twice. Again, if you raise something with a power to another power, you should multiply, which means we've done a cumulative 1/4 power to the 16, which means we've taken the 4th root. The 4th root of 16 is 2. I'm deliberately trying to pick out some of the really tricky ones here to make sure you see them. Again, practice the exponents worksheet if this gives you trouble, and let me know if you need more practice. I will track some down. Log base 4 of 8. Okay, so this is what power of 4 gives me 8. This one I find is the very trickiest for people, although it's sort of similar to the last one. The problem here is I need to make the 4 bigger, so it's definitely not 4 to the 1 because that would still be 4, but 4 to the 2 is already too big, so it's somewhere between first power and second power. So I'm going to get into fractional powers again. I would say the really key thing to notice here is that while 8 is not a nice integer power of 4, it is a nice power of 2. This is a 2 cubed and this is a 2 squared, so both of these are nice powers of 2, which means if I could start with the 4 and turn it back into a 2 by taking the square root, I'd be down to 2. I don't want to end up at 2, I want to end up at 8. So if I then cube the 2, which means cubing the 4 to the 1/2, I will get my 8. If I raise 4 first to the 1/2 and then cube it, that's a total of a 3/2 power. Multiply those powers. So fractional powers, negative powers, both really tricky. Make sure you give them some attention. Plan on seeing those on the test. And remember, you don't have a calculator. So practice, practice until you feel good about those. Okay, very last one here. We're supposed to take the natural log of negative e. So I'm asking myself, what power of e will give me negative e? And this one is really just to grab your attention. The answer is that's not possible, so this is undefined. One way to recognize that is just to remember that the domain of a log function, the thing you're allowed to plug into the log function, has to be positive. You don't want to mix that up for the rules about the base. That's not domain. That's just the definition of the function. So the base has to be positive and cannot equal 1. The input, that's the domain part, strictly has to be positive. So you can absolutely plug 1 into logs, but 1 should not be the base of your log. So this does not work. Another way to think about it is in terms of graphs. So if we think about this as I'm taking an e to the x and I'm trying to get negative e, we know what the graph of e to the x looks like. It's one of these. Negative e is in the ballpark of negative 2.7. This graph never takes on a negative y value. So it's not possible to raise something to a power and have that turn it into a negative number, to raise a positive number to a power and turn into a negative number. Whoa, doggy sneeze. Okay, so undefined, you cannot take the logs of 0 or negative numbers. All right, thanks for watching.